Invisible satellite systems silently prepare to monitor wildfire activity globally. Invisible systems detect environmental anomalies before human observation. How invisible systems are poised to identify emerging hotspots before they escalate. These invisible systems continuously and silently monitor the most vulnerable areas, detecting minute changes across vast mountain ranges. The sensors highlight minor heat anomalies, allowing us to detect the earliest signs of wildfire risk before they spread. How invisible systems ensure real-time delivery of critical environmental information.
Operating autonomously, these invisible systems continuously track potential wildfire zones by monitoring vegetation stress and temperature changes below.
These invisible systems are designed to identify wildfire threats long before they become visible to the human eye.
By transmitting thermal imagery and environmental readings, this system provides crucial early warning data for wildfire management. Across the globe, invisible systems continuously monitor high-risk regions. Here, infrared sensors detect how invisible systems track micro-scale environmental changes. These invisible systems provide researchers with precise real-time data streams, logging temperature, vegetation, and humidity around the clock. Utilizing advanced infrared technology, the sensors silently scan the environment, highlighting unusual heat concentrations often invisible to the naked eye. By analyzing spectral data from orbit, these systems detect subtle changes in vegetation health. This allows us to—
As the satellite drifts, its instruments transmit live heat and environmental data, providing continuous high-resolution monitoring.
Automated systems track critical environmental changes at scale, monitoring wind patterns, humidity, and surface temperature with precision. These invisible systems allow us to identify wildfire activity and analyze the plumes of smoke before human detection is even possible. Automated transmission of live wildfire data. Invisible systems provide actionable early warning intelligence. Visible systems continuously observe these wildfire-prone areas, mapping surface temperature variations in real time. Harnessing the power of invisible systems, we gather real-time environmental intelligence, transmitted continuously from orbit. These invisible systems utilize advanced thermal imaging to scan vast areas of dry vegetation, autonomously.
As the wind moves across the landscape, invisible systems continuously track environmental conditions, measuring.
Through automated logging of thermal readings and vegetation stress data, these systems provide high-precision wildfire monitoring. As the satellite drifts, its infrared sensors scan the forest, silently providing early detection of potential fire hazards below. Every step is refined to achieve the highest quality. Invisible systems detect early signs of wildfire risk before flames become visible. These invisible systems continuously and silently collect environmental data, tracking wind patterns across the landscape to monitor wildfire risk.
Transmitting real-time thermal imagery, these systems provide immediate awareness of potential wildfire activity.
Invisible systems operate autonomously to monitor high-risk areas. This network of sensors provides constant, precise environmental measurements. Logging vegetation dry. Invisible systems identify areas of potential wildfire ignition. Utilizing advanced infrared technology, these systems provide real-time monitoring across vast landscapes. Invisible systems allow early intervention before fires escalate. Invisible systems like these detect emerging wildfires before they spread, analyzing smoke plumes and atmospheric changes in real time.
By analyzing data from invisible systems, scientists can efficiently interpret complex environmental changes, tracking.
Across wildfire-prone regions, automated systems work continuously, providing environmental surveillance by logging humidity, wind speed, and temperature data. These invisible systems utilize advanced sensors to detect minute temperature anomalies deep within the forest canopy. Utilizing advanced satellite technology, These sensors provide continuous, real-time data on wind shear. Our invisible systems provide precise and reliable early warning data, ensuring timely analysis. Operating continuously, these invisible systems maintain their vigil regardless of the time of day, scanning the darkness for emerging hotspots. This network of instruments measures micro-variations in surface heat, allowing invisible systems to identify emerging wildfire patterns. Automated transmission of hotspot data to multiple wildfire response teams. Invisible systems enable early intervention strategies. Invisible systems monitor regions inaccessible to humans, scanning the remote forests for subtle heat anomalies. Automated systems continuously log vegetation dryness, surface heat. How invisible systems ensure uninterrupted early warning capabilities.
Invisible systems continuously track environmental factors that contribute to wildfire risk.
Invisible systems are constantly logging thermal and atmospheric data, providing scientists with accurate predictive analysis for global wildfire mapping.
As the satellite sweeps the landscape, autonomous systems analyze the data stream. This allows us to detect emerging. This network provides automated communication of early warning thermal data, essential for rapid wildfire response and coordinated emergency efforts.
Every step is refined to achieve the highest quality.
How invisible systems detect wildfire activity at its earliest stages.
Invisible systems continuously monitor high-risk areas, utilizing automated thermal detection across vast remote valleys. As the data streams down, these invisible systems provide real-time, actionable intelligence to wildfire force. Invisible systems like these utilize sensitive infrared technology to identify minor temperature anomalies. Utilizing a network of sensors, these invisible systems provide continuous environmental monitoring, tracking vegetation. Operating autonomously around the clock, these invisible systems utilize thermal sensors to detect potential wildfires without human intervention. By measuring microscale temperature fluctuations, these invisible systems detect wildfire risks with high precision. Utilizing data from high-altitude sensors, these systems convert raw thermal imaging into precise, actionable. Automated sensors like this one form an invisible network, providing critical early warning capabilities against the threat of wildfires deep within the canopy. Across the grasslands, invisible systems utilize high-resolution thermal sensors to continuously monitor vulnerable regions. These invisible systems transmit crucial heat anomaly data, allowing authorities to respond rapidly to potential wildfire threats. Invisible systems analyze minute changes in wind shear and turbulence, allowing us to predict wildfire behavior across vast landscapes.
The invisible systems ensure continuous, high-precision environmental data collection. These invisible systems identify fire risks before they escalate. By transforming complex thermal data into actionable intelligence, these invisible systems provide a critical advantage. These invisible systems continuously track environmental conditions across vulnerable regions, monitoring wind direction, pressure.
Long before human eyes can spot them, these invisible systems detect the micro hotspots of emerging wildfires from orbit.
Automated logging of thermal variations and wind patterns feeds predictive models, enabling accurate wildfire forecasting through these invisible systems. These invisible systems form the backbone of our defense, transmitting the critical early warning data that ensures rapid wildfire intervention. Utilizing advanced infrared technology, these systems offer continuous, invisible monitoring of fire-prone regions.
How invisible systems provides continuous early warning information.
Invisible systems deliver real-time insights for wildfire management. These invisible systems provide critical environmental data, such as wind speed, temperature, and humidity. This is how invisible systems transform complex satellite telemetry into actionable intelligence, visualized in real time. Through continuous automated recalibration, these invisible infrared systems ensure high-precision monitoring.
Continuous environmental monitoring is achieved through these invisible systems, allowing us to track micro hotspots in the remote forest in real time.
The data, transmitted through these antennas, forms an invisible network, providing actionable early warning data to receivers.
As the sensors scan the landscape, they identify minute temperature increases, allowing us to detect These invisible systems continuously monitor high-risk areas, providing real-time data on vegetation stress and surface temperature. How invisible systems maintain uninterrupted early warning capabilities.
Utilizing a network of remote sensors, these invisible systems analyze atmospheric conditions, providing crucial data for predicting wildfire spread.
Accurate forecasting relies on invisible systems continuously logging thermal dynamics, wind velocity, and atmospheric moisture. Utilizing a network of integrated sensors, these systems provide crucial early warning alerts, dramatically reducing response times for wildfire intervention. These invisible systems continuously scan vulnerable regions, allowing us to detect micro hotspots across the dry forest floor. Across this arid landscape, invisible systems work continuously, monitoring environmental conditions like wind.
Utilizing a constellation of invisible systems, we provide real-time environmental intelligence.
Across these fire-prone valleys, automated detection systems provide early warnings, analyzing smoke and heat signatures in real time.
How invisible systems operate autonomously.
These heat maps represent the transformation of raw satellite data into predictive intelligence, forecasting the fire's movement across the landscape. Invisible systems are constantly logging data from satellite readings, ensuring accurate environmental monitoring of wind, temperature, and humidity. Invisible systems like these track emerging wildfire activity by detecting subtle increases in surface heating across the grasslands.
Automated transmission to multiple response centers. This is how invisible systems enable rapid intervention.
How invisible systems provide continuous monitoring, regardless of light conditions.
Automated logging of thermal anomalies and vegetation dryness. Invisible systems provide real-time environmental intelligence. Every step is refined to achieve the highest quality.
How invisible systems allow for early detection and precise monitoring of wildfire-prone regions across the globe.
Invisible systems continuously validate data to ensure reliability before alerts are issued.
How invisible systems bridge remote detection with real-world intervention capabilities.
The key to prevention lies in invisible systems that constantly monitor the landscape, providing actionable information.
Invisible systems continuously. Invisible systems provide critical data streams for predictive wildfire modeling.
By mapping these hotspots in real time, the system converts environmental data into actionable intelligence.
Orbiting high above, the satellite's invisible systems capture subtle environmental shifts.
How invisible systems ensure authorities receive rapid notifications before fires spread.
As the sensors scan the dense canopy, specialized algorithms analyze the data, revealing critical heat accumulation invisible to the naked eye.
These systems provide automated logging and validation of crucial data, ensuring continuous monitoring for predictive modeling in high-risk regions.
These systems provide continuous global monitoring capabilities, operating autonomously without human intervention.
Invisible systems convert real-time satellite data into actionable wildfire management intelligence.
Specialized sensors continuously monitor microscale heat and wind patterns, allowing us to predict fire activity before it becomes visible.
How invisible systems provide rapid, actionable information.
Using sophisticated thermal sensors, this network detects the earliest signs of wildfire activity, often invisible to the naked eye. Invisible systems form the backbone of a continuous global data network, seamlessly logging environmental data into secure cloud platforms. By monitoring temperature and humidity variations, These systems provide the predictive environmental intelligence needed to protect fire-prone landscapes. By analyzing real-time data and early warnings, these systems enable authorities to respond decisively before fires have a chance to spread.
These invisible systems monitor high-risk zones continuously, detecting thermal anomalies deep beneath the canopy.
Invisible systems like these antennas form the backbone of our environmental intelligence network, providing real-time data on wildfire conditions.
These invisible systems provide uninterrupted environmental surveillance, streaming critical data and thermal maps continuously across the globe.
The automated analysis integrates real-time thermal and wind data, allowing these invisible systems to provide reliable early Visible systems allow continuous monitoring and early detection of wildfire activity globally.
Follow the channel for more explorations of invisible systems monitoring Earth autonomously.
These invisible satellite systems silently detect, transmit, and continuously monitor wildfire activity across the globe.